Good morning all. This is JONE ROSY, Assistant Professor, EC Department in SA Engineering College. In the last video, we discussed about what is a linear system, what is a time invariant system, and what are the properties of a linear time invariant system, as well as how to check the system stability and causality. So the problems related to causality, stability, that and all we have discussed in our last video. Now in this video we are going to find the impulse response of a linear time invariant system. So let's see the problem. Consider a linear time invariant system for which the input x of n and output y of n satisfy this difference equation y of n minus 1 by 2 y of n minus 1 is equal to x of n plus 1 by 3 x of n minus 1. Determine impulse response h of n as well as the transfer function h of z. So now let us solve this problem. Let us see how to find the impulse response h of n and the transfer function h of z for this given difference equation. So before start doing this problem, we should know how to take the Z transform for this given difference equation. For that, what is the formula of the Z transform? The formula of Z transform is x of z is equal to summation n is equal to minus infinity to infinity x of n into z power minus n. So this is the formula of the Z transform. So first what we have to do is we have to apply Z transform for this given difference equation. So let us see how to apply Z transform for this equation. So what is the Z transform for this y of n? For the Z transform for y of n is what? Y of z. Similarly, for this term y of n minus 1, how to apply the Z transform? We have to apply the time shifting property of the Z transform. So if you apply the time shifting property of the Z transform, this variable y of n minus 1 becomes Z inverse into y of z. Likewise, for y of n plus 1, if you apply the time shifting property of the Z transform, it becomes Z power 1 into y of z. Similarly, if you apply the Z transform for this difference equation, what you will get is y of z minus 1 by 2 into z inverse y of z, which is equal to x of z plus 1 by 3 z inverse into x of z. Now we have to rearrange this equation. So rearranging in the sense, first let us take y of z. These two terms have y of z common, right? So let us take y of z common from these two terms, and in these two terms we have x of z as common. So let us take x of z common from these two terms. So after taking this y of z and x of z common from these terms, so let us bring this x of z term to the other side of the equation. So after taking y of z and x of z common in this equation, what you have to do? We have to bring this term x of z to the other side of the equation. So let us cross multiply this terms. So what you will be getting? So y of z, this x of z will come over to the other side of the equation. Likewise, this one 1 minus 1 by 2 z inverse will come to the other side of the equation. So now we have obtained the equation as y of z divided by x of z. So the output divided by input is nothing but what? The transfer function. So that is is what? We have written it as h of z. So the output y of z divided by the input x of z is nothing but what? The transfer function h of z. So now we have obtained the transfer function for this given equation. So now in order to get the impulse response is h of n. So to obtain the impulse response h of n, we have to take partial fraction, we have to apply partial fraction expansion for this equation. So we have to apply what? The partial fraction expansion for this given equation. So we have to check whether for this equation can we able to apply partial fraction. So what is the rule for that? Obviously the denominator power should be greater than the numerator power. Now let us check the powers here. So z power 1 here as well as in the numerator we have z power 1. Both powers are same. So if it is like that, we can't apply the partial fraction. So now we have to bring this equation in a standard form so that we can apply the partial fraction equation. So that is our next step. So first let us take z common in the numerator as well as z common in the denominator. So we will be getting z by z, z plus 1 by 3 divided by z minus 1 by 2. So now actually to apply the partial fraction we should have the denominator power greater, right? So now if you bring this z term in the numerator to the other side of the equation, let us bring the z to the other side of this equation. So it will be h of z by z, which is equal to z plus 1 by 3 divided by z into z minus 1 by 2. So now what is the power in the denominator? Here we have z power 1, here we have z power 1, it becomes z power 2. And in the numerator we have z power 1. So now the power in the denominator is 2 and the power in the numerator is 1. So now for this equation we can apply the partial fraction expansion. So we have two terms in the denominator. So let us split like this: a divided by z plus b divided by z minus 1 by 2. Okay, so this is a divided by z plus b divided by z minus 1 by 2. So now what you have to do is we have to segregate the equation in order to find what is a, what is the value of b. So how to find the value of a and how to find the value of b? Let us take LCM, and now to get the value of a, let us substitute in this equation as z is equal to 0. So now after segregating this term as a and b, our aim is to get what is a and what is b. So how to find the value of a and how to find the value of b? So in order to get the value of a, we have to substitute z as 0 in this equation so that we can able to get what is a. So if you substitute z as 0 means this equation becomes a into 1 minus 2 plus b into 0 because we are substituting z as 0, right? So this term becomes 0 and which is equal to 0 plus 2 by 3. So we can get, so now this term b term becomes 0 so that we can get the value of a. So what is the value of a? A is minus 2 by 3. So as we have got the value for a, now it is our turn to get the value for b. So how to get the value for b? In order to get the value for b, we have to make this a term as 0. So in order to make this a term 0, what we have to substitute for z? So z we have to substitute 1 by 2. So what is the thing we have to do it for z? So for z we have to substitute 1 by 2 so that this a term becomes 0. So only thing which is left is b. So after substituting z is equal to 1 by 2, this term becomes 0 and now we have only a b in this equation. So we can get the b value. So what is the b value? B is 5 5 by 3. A is minus 2 by 3. So now we have obtained the A value and B value. So we can now substitute the A term, that is A value and B value in this equation. So after substituting A value and B value in this transfer function equation, we have to apply the inverse Z transform. So in order to apply the inverse Z transform, we have to check for the region of convergence. So region of convergence, based upon the region of convergence, we have to obtain the impulse response of the system. So before applying the inverse Z transform, let us check for the region of convergence. So for this first term, minus 2 by 3 divided by Z, and the next term is plus 5 by 3 divided by Z minus 1 by 2. Actually we require only that H of Z term, right? And we have one more term in the denominator. So we have to bring the denominator term to the numerator. So when you bring this denominator term to the numerator of these two functions, what you will be getting? This Z and Z get cancelled, and in the next term we have Z divided by Z minus 1 by 2. Okay, so now after changing this expression, we have to apply the inverse Z transform. So first we have to check the region of convergence, and then let us apply the inverse Z transform. So how to check the ROC? So for this first term, the ROC lies in the entire Z plane, because Z is equal to what? 0. And for here, let us check for the ROC of the second term. So for the second term, look at the denominator term. Denominator term is Z minus 1 by 2. Denominator term is Z minus 1 by 2. So to find the ROC, what are the possible region of convergence for this term? So the possible region of convergence is Z is greater than 1 by 2. Another possibility is Z is less than 1 by 2. So with these two region of convergence, one with Z less than 1 by 2 and another with Z greater than 1 by 2, let us apply the inverse Z transform. So first case we are considering is modulus Z is greater than 1 by 2. So if this condition persists, means what is the step causality, or it is a non-causal the system is a causal system if this modulus Z is greater than 1 by 2. That is why they have mentioned here as this system is a causal one. So with this condition, now let us apply the inverse Z transform. So inverse Z transform for this equation, H of Z is equal to minus 2 by 3 plus 5 by 3 into Z divided by Z minus 1 by 2 is minus 2 by 3 into delta n plus 5 by 3 for this term Z divided by Z minus 1 by 2. If you apply the inverse Z transform, what you will be getting? 1 by 2 power n into what? U of n. So this is the impulse response if the region of convergence is, that is modulus Z greater than 1 by 2. So for the first case, we have find out what is the impulse response. So now let us check on for the next case. The next case is the region of convergence for modulus Z which is less than 1 by 2. So if it is less than 1 by 2 means the system is what? The system is a non-causal system. So the non-causal, for this non-causal system and for this region of convergence condition, let us check for the impulse response. So to find the impulse response, again what we have to do? We have to apply the inverse Z transform. So the equation rewrite again. So H of Z is equal to minus 2 by 3. For this case, it lies in the entire Z plane, and then plus 5 by 3 Z divided by Z minus 1 by 2. For this term, the modulus Z is less than 1 by 2. So modulus Z is less than 1 by 2 is the ROC condition for this equation. So now let us apply the inverse Z transform. So the inverse Z transform for this term, the first term is minus 2 by 3 delta of n, and for the next term it is plus 5 by 3 1 by 2 power n into u of n. So this is the thing, this is the impulse response for the region of convergence, that is modulus z less than 1 by 2, and this is the impulse response for the region of convergence condition modulus of z greater than 1 by 2. So now in the next class, in the next video, we will discuss one more problem in getting the impulse response as well as the transfer function for the given difference equation. Thank you.